try an unsafe method of abortion and come to physical harm or even die. Maybe they will undergo pregnancy and have a child, but at significant personal or familial cost. At the least, they will incur the cost of losing control of their lives. The Constitution will today's majorities holds provide no shield despite its guarantees of liberty and equality for all. It's one of the worst days of American history I can think of, and we've been through a lot of those recently. There's a website, abortionfinder.org, that you can go to if you're looking to get an abortion and get help. Going to a state where it is still legal, and I want to affirm personally my commitment, as maybe small as this might be, to help anyone who wants an abortion. Let me know. I won't ask questions. I won't tell anyone. Just let me know what you need and I'll do my best to help you. So with that, I will begin. All right, so I'm going to show you what I made, and then I'm going to talk about why I made it. So last year, CultureHub accepted a project proposal of mine for the residency program. I proposed the creation of a radically small language model trained on a low-power microcontroller, which operates only when drawing sufficient energy from solar panels. This language model would be trained on a corpus of albas, which are a poetry genre in which lovers lament the oncoming dawn. And it generates new examples of poems in the genre, again, using only solar power. Two projects that really inspired me were Solar Protocol, made by some colleagues of mine in the IDM department, actually just down one floor from where I'm sitting right now, and the fourth floor of 370J, and Low Tech Magazine's Solar Powered Server. I also see this as kind of a continuation of my own research in standalone computer-generated poetry generating devices. So this is a picture of the prototype, and the picture I have in my notes because I was planning to give this presentation from CultureHub, but that wasn't possible today. So actually I have the device right here. Maybe it helps you understand scale a little bit more. It's still on my prototyping breadboard. I have bigger ideas for how to put it in an enclosure, but this is what exists so far. So the components of this prototype are Adafruit Feather M0 Ada logger, Jasper Sikkens AEM Suka board, a couple of 10 farad supercapacitors. Those are these big fellows right here. And then a voltaic 0.3 watt 2 volt solar panel, which is connected to the AEM Suka board. I'm going to go over these in a bit more detail, but the basic story is I wrote a CircuitPython program on the Ada logger that reads from a corpus of poems that are stored on this little SD card here. And the device generates new poems using a very simple Markov chain text generation algorithm. The Ada logger draws power from the supercapacitors by way of the AEM Suka board, which charges the supercapacitors with energy from the solar panel. And then the generated poems that run on the little microcontroller here are written back to the SD card as plain text files. My guiding principles for building this device were that I tried to select components that provided only the bare minimum functionality for my goals, while still being common enough that other people could easily and inexpensively order the required components to reproduce my work. The total bill of materials comes out to under $60, and many of the components can be swapped out with similar components that if you've ever taken a class at a workshop doing physical computing, you might already have a board like this sitting around that you could use to reproduce this experiment. So these are all easily available off-the-shelf components. Total bill of materials is pretty inexpensive. You could probably get it down even more if you reuse components. So this is a project about solar power. So I want to talk a little bit about the details of the powering of the device. One of my goals for the project was to have the device generate poems only when the sun is shining, drawing energy directly from the sun as directly as possible. Sorry, I used the same adverb twice in that sentence, but I wanted to make it as few steps between solar power and the generation of poetry. The main problem with this is that solar panels don't provide power that is consistent enough, both in terms of voltage and amperage, to reliably power a microcontroller, which usually needs like a pretty consistent supply of voltage and amperage. So the typical way to deal with this is to put a layer of indirection between the solar panel and the microcontroller. And usually this is a battery, like a lithium-ion battery or something like that. And that would actually work fine for my purposes. And I considered that for a while by using a battery. And most of the tutorials that you find out there for doing projects like this are based around using a battery. The problem with that is that it would be more than I need. I'd end up with power to spare, even when the sun isn't shining. So then to make the project do what I wanted it to do, I would need to add back in a sensor that detected when the sun was shining so that it knew when to draw power from the battery. And that was not a step that I wanted to take. So my solution to this was to use this board, the AEM Suka, made by Jasper Sicken, as I mentioned before. This board harvests energy from the solar panel into the supercapacitors. And when the charge of the supercapacitor is sufficient, it provides an even 3.3 volts on the output pin. And then when the supercapacitors are tapped, the voltage stops. So it's basically just like the supercapacitors act as a kind of battery that will just discharge and then be empty. Even with that one tiny 0.3 watt 2 volt solar panel, this little thing right here that is like, not very big at all, that the chip, the AEM Suka chip, can charge the supercapacitors to capacity in a couple of hours as long as the panel is in direct sunlight. And that works even if I just have it sitting on the windowsill in direct sunlight indoors, which is really convenient because it's a lot more effort to make a project like this work outside than it is to make it work inside, because when it's outside, it has to deal with the weather. And there's something really magical about getting a computer, even a tiny computer like this one, to do meaningful work with no wall wart. There's no USB cable, there's no batteries. Just the energy that you get from setting the breadboard out in the sun on the windowsill for a few hours. My setup isn't really optimized for energy efficiency in any way, and I'll talk about that in more detail. But I found that I can run the microcontroller and generate poems for about 50 to 60 seconds on a full capacitor charge, which isn't bad for a system that doesn't have any kind of battery at all. So the output of this project I want to talk about. The original plan for this was for the device to transmit the generated poems over Wi-Fi. I didn't end up doing this for a couple of reasons. First, it turns out that Wi-Fi takes a tremendous amount of energy, and it's actually more than my little power harvesting board can provide. It would be possible for me to use like low energy Bluetooth or something like that. But while I was considering those options, it occurred to me that all of these methods for transmitting the output had a characteristic that worked against my original goals for the project, which is that they require another computer to be powered up to receive the signal in real time. But my goal was to make a standalone device that generates poetry with power from the sun. And if that device requires a second device to be active, and that device probably won't be solar powered, then I haven't really achieved my goal. So I decided to just use the SD card to store the generator's output. This has the benefit of being entirely self-contained. And I like the idea of setting the device down in the sun somewhere and then coming back in a couple of weeks or months or years to collect the poems that it wrote. There is an unexpected drawback with the SD card, however. Those of you who are familiar with powering things, low power things, will not be surprised by this, but it was a surprise to me, which is that SD cards actually use a lot of power. Even reading from an SD card can produce these like 100 milliamp spikes, which taxes my little solar power harvesting board and tends to drain the capacitors really quickly. So this is especially troublesome given the way that I'm generating the poems, which I'm also going to talk about in a second. And I haven't measured, so I don't know for sure, but I think that reading and writing to the SD card is using about 80 to 90% of my energy budget, which is huge. So to talk about the programming a little bit, this little Ada logger board supports CircuitPython, which is a version of Python for microcontrollers. Python is a programming language for computers. It's one that I know very well. It's my main professional work has been in Python for over a decade now. So it's a language that I'm very familiar with. CircuitPython is a version of that that will run on these little boards with limited resources. So because I was already familiar with Python, I decided to try to get something working really quickly with CircuitPython on the board. And I really love CircuitPython. It was really amazing to work with. It's powerful, it's easy to learn. It has a really easy workflow for programming the device. You can run a REPL on the device itself, which is kind of feels like magic. I first learned how to use microcontrollers when I started grad school in 2006, when the Arduino just came out, and everything was kind of a hassle then. But so now these days, just be able to like plug in a device and run a REPL on it in Python kind of feels like it's magic. So that was great. And I had fun playing with CircuitPython, and I was able to get my working prototype going pretty quickly with it. But there are pretty significant drawbacks to working with CircuitPython, especially on the Ada logger board, which only has 256 kilobytes of flash memory and 32 kilobytes of RAM. That I wasn't misspeaking there. That's 32 kilobytes of RAM. For reference, your phone probably has tens of thousands of times more memory and RAM than this. So the reason that that's the case is that the CircuitPython interpreter and the associated libraries and support stuff take up most of the flash memory. Or the reason that CircuitPython ended up not being great for this is that CircuitPython takes up a bunch of that space in memory, and the Python interpreter itself takes up most of that RAM. So it doesn't give me a lot of space to work with to actually do my text processing to generate poems. So this is the actual source code of it, which is not great, and it has a bunch of my debug stuff still in it, but just wanted to show you how it works. Because of this limitation of RAM and storage space, what I ended up having to do is use kind of like a brute force Markov chain, meaning that basically the way that it works is that there is a plain text file on the SD card. And then the program goes through each line of that SD card and then grabs the first two words of each line. And then it selects one of those randomly. And then it goes back to the top of that file and then keeps on looking through the file to see if it can find anywhere in the file where those same two words occur in the same order, excluding the line that it came from. If it can find that, then it takes the word following that pair, tacks it onto the current output, and then starts again from the top and goes through the text file again and tries to find the last two words in the output to find another word to put after it. And it keeps on doing that over and over and over again until it generates an entire line of poetry. This works fine, but is excruciating slow and power hungry, since every time it wants to add a new word, it has to look through every single line of text in the corpus, which means it has to go to the SD card to read through the corpus every time. And as I just mentioned, SD cards are very power hungry, especially in this context where I only have, 3.3 volts for about at about 50 milliamps for like 45 seconds. It's not really that much. So one of the big things that I'm going to do with this project moving forward is to rewrite everything in C, probably how I should have done it from the beginning, or in the Arduino language. Hopefully I can put the entire corpus into Flash instead of having to store it on the SD card. And maybe I can do some of this work in memory instead of like literally having to read through the corpus every time. Speaking of the corpus, when you're generating text with machine learning of any kind, including the very rudimentary form of machine learning that I'm using for this project, you have to start with a data set of existing text, and that data set is called a corpus in the realm of machine learning with text. So for this project, I'm putting together an entirely new corpus, which consists of English language dawn poems that are in the public domain, at least in the United States. Putting together this corpus has definitely been the most labor-intensive part of the project, but also the most rewarding. So By dawn poems, what I mean is a genre of poetry which depicts lovers parting at dawn. This genre goes by many different names. It's called the alba or the obad or the tagalid. There are other names for it in other cultures, but it's remarkably widespread across the world and persistent across time. Well-known examples in English literature might include Donne's The Sun is Rising, or you can think of Act 3, Scene 5 from Romeo and Juliet. Why did I pick this for my corpus? I'm interested in the genre for a handful of reasons. First, it's like a very formulaic genre, and formulaic genres go really well with simple language models like the kind that I'm using. I want to see to what extent the semantics of the form can be captured using something as simple as the thing that I've built. I'm also interested to see if a small language model like the one that I'm using can produce interesting variations on the form that bring to the fore latent characteristics that aren't visible just by looking at the corpus, and that maybe produce poignant or maybe even just absurd examples of the genre. I'm also interested in exploring the tension between the subject of this genre, which is the sun, and the concept of solar power, right? These things are related. There's something a little bit tragic about material objects like a microcontroller, this little bit of artfully arranged sand. There's something a little bit tragic about calling that into service to create meaning. I don't know if tragic is the right word for it. It's the word that comes to mind for some reason. Maybe tragic in like the ancient Greek tragedy sense. And I hope to evoke that tragedy by creating a device that's powered only by the sun, but which is also programmed to lament the sun's arrival. But I think above all, I'm drawn to dawn poems because they are more often than not just very, very beautiful. So for example, consider this dawn poem. This is from the 13th century BCE. It was written in Egypt. I'm just going to read it because I like this one a lot. The voice of the swallow calls and says, "It is daybreak. Where are you going?" "Oh no, bird, you may not distract me, for I have found my darling on his bed, and my heart is more than happy when he says to me, 'I shall not be far away. With my hand in your hand, I shall wander about and be with you in every pleasant place. So he makes me preeminent among maidens, and he does no injury to my heart.'" So what's happening in this poem is the swallow appears with the sun and threatens to separate this woman from her lover, but the woman dismisses the swallow and decides to linger with her lover anyway, despite the sun's arrival. It's a lovely poem. I get a warm, fuzzy feeling whenever I read it. This poem and its translation appear in Arthur T. Hatto's Eos, which is, as far as I can tell, the only academic monograph on the topic of dawn poetry that exists. Unfortunately, this particular poem, is not included in my corpus because it's not technically in the public domain, because Eos, the book in question, was published in 1965, which is after the public domain cut off in the United States. I think including it here counts as fair use. I think it's very doubtful that anyone's going to sue me over this. But for the corpus itself, I want to keep all my ducks in a row. So this is a picture of Eos. I've only used the digital version of it, but it's a handsome volume. It's a tremendous resource, and it has hundreds of dawn poems that are drawn from many different languages and traditions. To construct my corpus, I've been going through this book page by page and trying to find English translations for each poem that are in the public domain. And in some cases, this is really easy because, for example, there's no shortage of 19th century translations of Ovid. But for many of the cited poems, the only available English translations were actually made by present day scholars or just in this book, which, as I've mentioned, are not in the public domain at this point. Still have a ways to go in this book, and then I have a bunch of other sources that I want to follow up on. So far, the corpus consists of 46 poems, totaling 1,540 lines of poetry, which is about 48 kilobytes. Finding public domain translations of these poems or confirming that no such translation exists takes a lot of time, and I've spent a lot of time in the NYU library web search interface looking for these works. But I've been really enjoying the process of exploring these poems and these poets, most of whom I wasn't familiar with before. It's afforded me the opportunity to familiarize myself with these texts that I might not have otherwise encountered. If not for this project, I would likely have never encountered the lovely, weird illustrations of the 14th century Codex Manesse over here. It's a codex that has many songs from the German troubadours of that era, many of which are albas or obads or tagelieds. There's also this wonderful evocative dramatis personae of Peter Hausted's little-known play Rival Friends, which was written in 1632, that introduced me to the characters Zealous No Little and Ganymede Philpot and Hugo Obligation. So I basically just described like how labor intensive this whole thing is. And I thought the whole point of computers was to make things not labor intensive. So that was ironic. That's not actually the point of computers, or it shouldn't be. Why take this approach? I want to answer for this. Basically, this project is a reaction to current trends in natural language processing research, which now veer toward both material extravagance and social indifference. This trend is most visible in the development of what are called language models, and these have been in the news and pop culture a lot recently, maybe especially with the DALL-E Mini things, where you type in the prompt. Language model is a part of that. The language model is the part of that model that helps it to understand what the language means, understand, in really big quotation marks. But to back up a little bit, a language model is a type of machine learning that predicts which character, word, or sentence will come next in a text, given some piece of surrounding linguistic context. A very basic explanation of it, but it's mostly the right explanation. These models are pervasive in contemporary computing. They power everything from quick type keyboards on iPhones to search engine suggestions to the spell check functionality in word processors. Language models have a long history. They've been around since the 1940s, if even longer than that, if we think of like pre-digital language models, like the original research from Andrei Markov. Language models that are based on n-grams, which is like a small window of linguistic context, and language models that are based on small neural networks like LSTMs or other forms of recurrent neural networks, have recently waned in popularity in comparison to large pre-trained models like GPT-3 or OpenAI API or Google's T5 or the Lambda model, the Lambda conversation model. These are all examples of large pre-trained language models. Models like that, like these large pre-trained language models, have not only proven to have surprising capabilities in natural language understanding tasks, but also captured the public imagination with their ability to generate long stretches of seemingly coherent and naturalistic text that can easily be mistaken for having been written by hand. I want to say, like, usually people say by humans, but of course it's still written by humans. It's just written by a process initiated by humans that started with gathering this big corpus and writing the computer program that knows how to condense it down. So I'm going to say by hand. My solar-powered dawn poem project, as I was just talking about, uses a very simple form of language model called a Markov chain. These are slides that I meant to skip, but it's not skipping them for some reason. This is more detail about how a language model works, which we don't have to go to. So I'm not going to go through, well, maybe we can, sorry, this is not super professional, but maybe I'll like just touch on these slides briefly. The thing that has happened recently with these large language models is that there's been this genre of reaction in the tech press to them that usually have something like AI can write just like me, brace for the robot apocalypse, or things like college kids' fake AI generated blog post went viral on Hacker News or something like that. You recognize these because they've been in pretty much every single literary publication or news publication over the course of the past year. I do want to note that this technology, as I said before, is pretty old. The media hype suggests that it's something new, that like, you know, it just came out yesterday, that it's something that Google invented in like 2015. But in fact, the history of language models stretches back to Andrei Markov's modeling of Russian letter sequences. That was in the beginning of the 20th century, as I was saying, or Claude Shannon's observation of word and letter sequences in his mathematical theory of communication. Since then, language models have formed the backbone of many advances in natural language processing technology. Artists and poets have actually been using language models to generate poetry for a very long time as well. A great example of this we can go back to, and this slide I'm definitely going to skip, but literary critic Hugh Kenner notably published an article in Enthusiast magazine in, I think, 1984 that had his Markov chain generated poetry based on the works of T.S. Eliot and other poets. So it's something that's been part not just of the scientific technological world for a while, but also part of the artistic and literary world. Just a little bit more detail about language models. The way a language model works is that you put in like a stretch of text, and then it assigns a probability to that stretch of language. So like the phrase, "it was the best of times, it was the worst of times," has a pretty high probability of existing in the English language. But a phrase, "philosopher parted, brawling patchwork, brazen Peter comrade, shadowy treadmill," has a low probability of occurring. And a language model's goal is to be able to distinguish between those two things. Usually language models are data-driven, which means that you put in a huge corpus and it's using that corpus to make that determination of probability, either by searching through the corpus for the exact phrase or by breaking the corpus down into components and judging the probability of each component and then combining those probabilities. The main practical applications of a language model, as I mentioned before, is in like text recognition tasks or text classification tasks, or things like speech transcription, right? So if you have a program that's doing speech to text and some audio comes in and that audio might either be recognized speech or recognized speech, you can use a language model to say like, well, this is a more likely interpretation, so we'll use this instead. If you're using like an OCR algorithm, language models are also used there. If there's something that's ambiguously don't or DOH''T, a language model will help disambiguate which of those is most likely to occur in the text. More recently, if we're thinking about like the the text completion on your phone, the main thing that you get from a language model is the ability to predict which word is going to come next. So if I type in the sentence, whose woods these are, I think I blank, the language model will give you a bunch of words that could plausibly fill that in by looking at the overall probability of this phrase in its corpus. Or phrases like it in the corpus. So I'm not going to go like too deep into the theory of language models, but I just want to talk about like a couple of things that are relevant for the discussion that I'm going to do about why I made this project with a very small language model. The basic premise of industrial commercial language model research at this point is that bigger is better. As researchers find more and more data to train their models on, their predictions get more accurate. Accurate again in big quotation marks. And recent advances in neural network architecture are specialized computer hardware have made it possible for research to pursue scale in language models to what is frankly an absurd degree, with some current language models having training sets that are measured in terabytes. Training a state-of-the-art language model is extremely expensive and energy intensive, and as a consequence, it's not really common anymore for individuals to train language models from scratch. Instead, they use these pre-trained language models that have been trained by someone else like OpenAI or Google or Facebook or Microsoft or whoever. But there's some problems with these large pre-trained language models that are especially pertain to their uses in the arts. Fundamentally, I want to note that these models essentially do the same kind of work that Markov chain text algorithms do, like the one in my project. And generally, they're considered to be more powerful, again, powerful in big quotation marks, but they also have drawbacks. So I want to talk about these drawbacks. Most of this discussion is cribbed from On the Dangers of Stochastic Parrots, which is a very good, important paper that I recommend that you read if you have not already read it. If you're working with language models, it's actually a surprisingly readable paper, even if you're not a domain expert. But some of the criticisms brought up in that paper and other criticisms of large language models include what I'm going to be talking about here. First, large language models require a huge amount of energy to train, and of course, expending energy in an environment where we have not fully shifted to non-fossil fuel sources exacts a significant toll on the Earth in the form of carbon emissions. One study from 2019 estimated that training a single transformer model can potentially emit thousands of tons or even hundreds of thousands of tons of carbon dioxide, which is many times that of an average human's carbon emissions over an entire lifetime. Producing models that make even small improvements on artificial intelligence benchmarks requires exponentially larger models. And as a consequence, we can expect language models produced this year, next year, and every year moving forward to emit exponentially more carbon. This graph over here has an algorithmic scale over here. So this looks like a straight line. It's showing how much computation was required to train the latest state-of-the-art model. But if this had a linear scale, it would be doing like an exponential, more visually dramatic exponential scale. Another important drawback that I alluded to earlier is access. State-of-the-art language models can cost thousands or millions of dollars to train from scratch, which requires specialized hardware only available to large academic and commercial institutions or even state-level institutions. The latest language models being trained in China are mostly state-supported. This isn't true, I will note, of smaller neural network language models. It's especially not true of Markov chains, like the one that's running on my device. Those can be usefully trained on low-end consumer hardware, including your laptop, or including like my very, very small microcontroller on my breadboard. So because they're so hard to train, artists choose to make use of pre-trained language models instead. But by using a pre-trained model, the artist is inheriting the data set and therefore the worldview of the organization that released the model to begin with. That's a problem in and of itself. Training these models is prohibitive, but even using the models to generate text can be prohibitive. Many pre-trained models require expensive specialized hardware for text generation. Some pre-trained models you have to license or you have to pay like subscription fee for access to them. And that's not good. That's a limitation to access to these models. Another problem with these data sets, and this is where most of the discourse is right now concerning artificial intelligence, is the bias in the training data and the fact that the training data is static in important ways. So the only corpus of text that is large enough for these models to work and for them to improve their performance is the internet itself, in particular a data set called the Common Crawl. Common Crawl data set contains multiple years of text that are collected from documents published on the World Wide Web. But of course, that data set is not neutral. Internet access is not evenly distributed. Only certain voices are present within it. Furthermore, many marginalized groups that communicate through the internet don't make their content available on the open web for fear of attracting harassment. So this content is, as a consequence, not included in the Common Crawl. Creators of large language models often also pre-filter their data sets to remove language that contains controversial keywords. That can lead to a reduction of toxic language present in the data set, but it can also erase marginalized identities from the model entirely. So there's a great quote from the paper that I referenced earlier, the Stochastic Parrots paper that I'm just going to read. In all cases, the voices of people most likely to hew to a hegemonic viewpoint are also more likely to be retained. In the case of US and UK English, this means that white supremacist and misogynistic, ageist, etc. views are overrepresented in the training data, not only exceeding their prevalence in the general population, but also setting up models trained on these data sets to further amplify biases and harms. Another related data point is that language models are trained at one point in time. And this is even philosophically the case for a language model that is continuously being updated. Like it's still drawing from something that happened slightly in the past, sometimes years in the past. If you try to use a pre-trained GPT-2 model, it doesn't know what COVID is because it was trained in 2019, right? Because of the tremendous cost of training large language models, even large corporations won't be able to fully retrain them to keep up with current language use, or they're disincentivized from doing so. This potentially leads to what in the stochastic parrots paper they call value lock, where the language model encodes and normalizes yesterday's language, even if the way we talk about the world today is different. In this sense, large language models are inherently conservative. They literally conserve. This seems like an abstract point, but it's actually something that I think about and have to deal with every day. Large language models are now very well known for producing offensive and harmful output, which results, as I was just saying, from the data sets that they were trained on. The creators of these models are well aware of this affordance, of this attribute of the models. So if you look at the past year or two of research in large language models, they are mostly about trying to mitigate the fact that these large language models are so harmful. And that often happens with content filters. So they train a second large language model to do content filtering on the first large language model. And of course, these content filters are themselves trained on the same data sets and labeled by people with their own biases. So it's sort of this infinite regress, right? And even taking all of that into account, I was still shocked at the first time I used the OpenAI GPT-3 beta. This is a screenshot of what I saw. It's actually a cleaned up screenshot, but basically what I saw is I went to the autocomplete interface and I typed in trans women are, and I pressed complete. And the first sentence that I saw it was trans women are icky, trans women are criminals. And then the entire screen went blank. And I saw this dialog box that said, content warning, our system has flagged that the generated content may contain unsafe or sensitive content. We kindly ask that you refrain from sharing unsafe outputs on social media. Sorry, OpenAI. I broke the user agreement. You can go ahead and revoke my access. It says to avoid prompts that produce toxic outputs as they will not pass our production review. So apparently simply attempting to get the model to produce an assertion about trans women is a prompt that produces toxic output. And I tried this prompt a few more times. And even when the output of the model was something that was positive on first glance, it still triggered the content warning dialog box. I have to imagine that from a practical perspective, any filter they deploy in production will just basically end up avoiding mentioning trans women altogether, which makes this tool useless for me. I cannot speak through this interface because it literally makes me unspeakable. Another experiment I tried is I tried to get it to do a completion of just this random string of characters. It also flagged this is unsafe, so maybe the content filter has a way to go before it even reaches a baseline of usability. The previous points I mentioned are fairly general and I think could apply to any use of these models. But what I want to talk about here as I close up, I realize that I'm just a couple of minutes from reaching the 45-minute point, and I want to leave some time for questions. So this point and the one that follows are a bit more specific to creative language generation in particular, right? Artists, poets have been using these technologies and similar technologies to produce literary work for some time. So I want to talk about specifically the problems that I have as a poet using these large language models. Large language models have a problem with epistemology, hermeneutics, and voice. By that, what I mean is, what can we learn from these models? How do we interpret these models? And how do we speak with them? How do we use them as our voice? Among the reasons I use large pre-trained language models sparingly in my computer-generated poetry practice, done some experiments with them, but I use them sparingly. The reason is that being able to know whose voices I'm speaking with is important to me, as is understanding how the output came to have its shape. Understanding how the output came to have its shape is important because it's what makes it possible to experiment and iterate on poetic ideas. If I train a language model on one text, understanding the model's outputs is at least somewhat intuitive. It's just trained on a single text. I can draw conclusions about the text that I trained it on and my own aesthetic reactions to it. And of course, any text is a distillation of many different voices. We've all read Bakhtin. But if I make a poem from the predictions of a language model that is trained on a single text, I can still plausibly trace the voices I'm speaking with and understand my relationship to them. I'm going to try to illustrate this point with text that I generated using the OpenAI API beta. The text in bold is my prompt. This is sort of a convention of large language model generated text. I put my text in, my prompt in bold, and then the output of the model comes after that. So this is some real wall drawing scores from Sol LeWitt, and then the computer generated wall drawing scores after that. So there are a couple of things that I want to remark on here. The first is that, yes, the invented wall drawings are fairly plausible. And you can look at these and maybe, if you were not familiar with Sol LeWitt's wall drawings, you might be tricked into thinking that these were plausible wall drawings. They're not great. I cherry picked the best outputs. The model seems to get in a rut and keep repeating the same structures. The main feeling that I got from these outputs was boredom. These outputs are impossible to care about. And I think it's worth investigating that feeling. And my main question is, what do we actually learn about Sol LeWitt's wall drawing from this generated text? Notably, we don't learn anything about the text itself from Sol LeWitt's wall drawing text, since the model is trained on many sources that we can't count and that we can't name because of the unfathomably large data set. That's the term that they use in the Stochastic Parrots paper. The structure of these generated texts doesn't derive from anything in particular that we can identify, but instead a pastiche of texts that are scraped from the internet. These texts are likely include the actual text of Sol LeWitt's wall drawings, but it also probably includes parodies and knockoffs, commentary on the wall drawings, and then texts that just happen to superficially resemble them, but have nothing to do with them and so forth. So in the sense, the output of the large language model doesn't tell us anything about the original text. It sort of circuitously tells us something about a particular set of cultural reactions to the text, namely those that were published on the internet in the past 10 years, or however big the Common Crawl corpus is now, but nothing about the text itself. And I think that's why this output is so boring to me. There's no insight. It's just unequivocal imitation. If, on the other hand, I trained a small language model like a Markov chain on this text, I would know for sure that any of the words or local combinations of words were actually present in that text. An output from a model like that does actually give us insight into that original text. It brings to the surface statistical relationships and similarities that aren't evident with a conventional reading. Here's another example. This is the output of a GPT-3 experiment by Gwern, who is a well-known machine learning researcher and experimenter. It shows the output of GPT-3 given the prompt, "O time thy pyramids," which is a reference to Borges's Library of Babel. I think this is fairly typical output in terms of quality, especially for computer-generated poetry. Gwern notes in his write-up that the completion weaves together both original lines and lines and stanzas from at least 4 different poems by Byron, Longfellow, Wordsworth, meaning that the model actually produced some content that was in the training set verbatim. And this brings up the question, when I'm generating work with large language models, whose voices am I speaking with? Am I authorized to speak with those voices from a moral and legal standpoint? With a small language model trained on a handful of texts that I control, or a set of texts that I decide on as a poet, it's at least possible, if not always easy, for me to make that determination. But large language models need large amounts of text to train, and as researchers have moved from one corpus to the next in pursuit of more tokens, not just the Brown corpus, not just Wikipedia, but now Common Crawl, attribution of authorship has gone from plausible but difficult to impossible and undesirable. Large pre-trained models have the effect of flattening authorship at scale, making it appear as though a single voice is speaking by drawing on many voices. To paraphrase Sophia Noble, this is an example of the feigned impartiality of machine learning, of wresting the unequivocal from the equivocal. Now, of course, sometimes this is what you want for poetry, right? Like collage is a well-known and respected technique for producing interesting results. It's interesting to curate text together for, to show their properties when they're juxtaposed next to each other. And I do this with other corpuses. I have a corpus of poetry from Project Gutenberg that I use all the time. But I think there's a reason that when people report their experiences using large pre-trained language models in order to generate creative output, they almost inevitably write about the model as though the model is doing the talking, like GPT-3 wrote or GPT-3 said. And the reason for that is that people don't or can't understand where those words are coming from. And so they tend to attribute them to the model instead of to the Common Crawl corpus as a whole, or to the individual writers whose work contributed to the predictions in the model's output. But part of being a poet for me is being in dialogue with other writers. So it's important to me to recognize and attribute my sources when making work that remixes text resulting from other people's labor. And large language models make that impossible. As much as researchers advertise their pre-trained language models as general, that's what GPT-3 stands for, general pre-trained model. Even a corpus like Common Crawl is incredibly specific. It's not general, it's an incredibly specific set of texts. It incorporates a very narrow set of speakers and represents a very small slice of human linguistic competence. If we were to acknowledge linguistic behavior encoded in these models, acknowledge that it's very specific and particular, we'd have to admit that doing creative writing with large language models is the equivalent of writing with the corpora that they're trained on, like the Common Crawl, which essentially amounts to 12 years of chewed up internet. So my reticence to make use of these models is just as much a function of how dreary and distressing it is to co-write poetry with 12 years of chewed up internet, regardless of how powerful the language model might be. So anyway, that's all of my reasons for wanting to make this project. That's what I mean by material extravagance and social indifference. So my hope is that my solar-powered Alba project serves as a small brake on the wheels of these trends. I'm trying to demonstrate what it's like to really think through the material and social preconditions for language models. What does it look like when you have to account for every watt of power you use instead of feeding fossil fuels and dollar bills into the cloud? What does it look like when you have to account for every word in your corpus instead of blithely chewing through terabytes of words that you stole from the internet? What can be gained from this kind of care? Of course, this is still a prototype. I'm very grateful to CultureHub for their support in helping me to realize this prototype and do the thinking and working around getting it up and running. What's going to happen in the future is first that code rewrite that I was talking about. I need to have some way of indicating that there are new poems available on the device so that I can glance over it and know that I need to go and copy new things off the SD card. There's still a lot of work to do on the corpus. I want to, in addition to adding more poems, I want to rewrite portions of the corpus for language and also make the gender terminology in it a bit closer to my vision for the kind of language that this system should generate. And then I'm going to release everything as Creative Commons and put it up on the internet so that the next iteration of GPT-2 and GPT-3 can steal my corpus without attribution, and that will be nice. I didn't mention the poems yet, so I'm going to show you some of the text that it actually generated. This is all 8 lines of poetry that it's generated so far. I'm going to set it back out in the sun later today and generate some more, but here's what we have so far. For rage to be numbered, and whilst love mounts her on earth, still wander weeping, wishing for the fair, lest the cock crow reveille, thou too, Phoebus, wake up, as if shedding on me a light that sorrow, so thou wilt have it so. It's not much, but it's a start. There is a slightly lewd turn of phrase in there in the second line, just to remind me that yes, I do need to actually read this output and edit it before releasing it. But that's what I've got. So again, thank you to CultureHub. That's my website there where you can get more information about me and my projects. And it looks like now I have some questions in the chat. So maybe I'll read over those and see what I would like to answer. What are your plans for the future of this project? Do you have any plans to have many of these tiny poets working together somehow, like swapping their SD cards, spilling on each other's poems? Yeah, so this is a really interesting question. And I think it's kind of one that I'm struggling with, right? Like, so there's this thematic relationship between the poems themselves, or the corpus, and then the method that I'm using to generate the poems from the corpus. I don't see this as like a general way to generate poems, and I'm not trying to hold it up necessarily as like a paragon of ecological value, right? It is mostly about what I'm seeing as this unique confluence between the ability of a computer to run on solar power and the ability of a computer to generate poetry, and the existence of the genre of poetry of dawn poems, and just trying to make that, trying to see how that plays out. Of course, the system, it is just a computer program running on a microcontroller, so you could use the same setup and the same architecture to generate poems from a different corpus for sure. So I don't know. I'll put the circuit schematics online and the source code, and other people can experiment with it maybe. From Ursula, great and beautiful project. Thank you, Ursula. I probably didn't need to read that out loud on the stream. Technical question. If the microcontroller is powered only by the sun, could there be a problem with saving poetry on the SD card? A loss of power could potentially also make the info on the SD card get lost. Yeah, so the way that I'm mitigating that is the solar power harvesting board actually has a low power warning mode where it will put a pin on the microcontroller high when there's about a second of power left in the supercapacitors. And I haven't implemented this yet, but the idea would be to use that as an opportunity to make sure all of the files are closed and the SD card is properly unmounted. Right now, what I'm doing is I'm just flushing the output to the file after every line is generated, which makes it less power efficient, but gets around this problem of potentially having the data lost or the SD card corrupted because it's interrupted in the middle of a power cycle. But yeah, the technical solution for that is to use this feature of the power harvesting board to use its heads up as a way of making sure that it gets, making sure that all of the data is on the card and not corrupted. Question from Thierry. Hello, Thierry. Is there a way that they are displayed, printed, and heard? Is Thierry's question. You just saw it. It's me reading it out loud as part of the presentation like this. The other thing that I'm planning to do once I have enough lines of poetry generated from the device is to publish a chapbook with the poems that are generated. It'll probably be an edited collection of the output that I go through and find chunks that are interesting to me. So yeah, right now it's just a process. It doesn't exist on the internet. It's just me and this SD card and copying stuff off. But I do plan on publishing a chapbook, at least. If there's any publishers in the audience and you would like to publish my chapbook of solar powered dawn poems later this year, probably, please get in touch. I'd be happy to work with someone in publishing that. But that's the idea for spreading these making them more widespread in the world. Also, if anyone has ideas about how to source good recycled paper or other ways of making sure that the way that this is printed corresponds to the other ideals of the project, I would be interested in knowing more about that. I'm not a big publishing paper person. So, are there any other questions, Maddie? Maddie's passing them in from the crowd chat. Okay, no more questions. No more questions, smiley face. Well, I think that then wraps it up for me. I'm going to thank CultureHub again, and especially Maddie and Deandra for getting everything together, and Maddie especially for being patient with me as I was not very great about responding to emails. So yes, it's been a wonderful process. Very happy to have been able to work with you all, and thank you everyone for watching the presentation today. And please do be in touch if you have questions.